about that chat. Hopefully I'm going to be able to see all the chat. We've got Twitch, we've got YouTube. Hopefully both. Got this working on Twitch, and then I think it tweeted. But I'll add a link. My chat. Beep boop. I think everything's set up. Luckily, because of that test stream earlier. Next. All right, so a little early. I guess we got another minute and then we'll kind of get into the intro. But do say hi in chat just so I know that chat's working. You know, it'd be good for my eyes though. It's glasses. All right, we're streaming on Twitch, we're streaming on YouTube, I think, and I guess on Twitter, which Twitter's doesn't let you chat, so I posted a link to Twitch. Since I normally stream on Twitch, nothing this interesting, usually just doing my work, sort of work on stream most of the time when I'm programming. Oh, that's something I should bring up too. So I imagine most people that are ending up in here already kind of know me or familiar with some of my work, but I've been working on this system called Tractor for the last couple of years. Worked on a lot of stuff before that, so I'm going to put up my GitHub sponsors page when we get started, just to show you what it looks like in case you're ever interested in seeing what it looks like. Because I'm working with a number of contractors and my current sponsorship does not cover them, so so I'm paying for a lot of this development myself, which is fine. It's not very sustainable. I'm a big fan of my Golang GitHub FS. FS, is that... oh, is this my YouTube video a long time ago? If you're coming in from YouTube, I've not been posting a lot of stuff to YouTube since I've mostly been working on Twitch, and a lot of the stuff that I post on YouTube were fairly old projects, and most of them are most of my work is pretty experimental, trying new things, and sometimes they end up being open source projects. But yeah, thanks for that, because I might actually do some more stuff for YouTube. I actually want to do more videos, a little bit more produced videos on YouTube pretty soon here. And I used to have stream to YouTube regularly as well, but I figured it was easier just in terms of setup and stuff to stream to Twitch most of the time. And then just for special events like this, I can do both. We'll see how it goes. But thank you for joining me from YouTube. And definitely follow me on Twitch if you can. That's where I normally stream. So today, I originally called this a Svelte source deep dive because I felt like I was going to spend a lot of time looking at the source code for Svelte, which is a web framework you may have heard of. You might not have. Which is fine. We're going to get into it and kind of talk about why I think it's cool. And kind of, this isn't necessarily, so I am going to kind of talk about and share and explore using Svelte, but mostly as a way to sort of map out what it does, because what we're going to try and do is sort of map that to the source code as we look at the source code, just to get a sense of how it's made. And this is originally something that was really for me, in case I wanted to make my own kind of Svelte framework for various reasons. Yeah, we're going to get started in a couple more minutes. And earlier in my test stream, I had chat on the screen. I'm not going to have it on the screen because I don't have a way for it to like disappear. Right now I didn't want to set that up, but I'm watching chat, or I think I am. I mean, obviously I have the YouTube pop out. I don't know why it didn't show up over here. This is supposed to be the restream chat. So I figured I might not be able to trust that, so I also have the YouTube chat and Twitch chat separately if I don't look at them every now and then. I don't know. Spam the chat. All right. Actually, let me check. Let me keep this chat thing open just in case. Okay, so I'll warn you, we're going to be watching some YouTube videos. So it's a stream of me watching YouTube videos, but I'm going to try and kind of keep them pretty condensed, mostly because I don't like repeating stuff. And all right, is everybody ready? This is live on Twitch as well. Oh, look, and the restream chat works. I'm gonna have a hard time with that name. Rajwal. Maybe that's close. Thanks for joining. All right, let's get over to a main thing here. Like I said, real quick, this is my GitHub sponsors page, github.com/sponsors/program. If you've been following my work on Tractor, awesome. If if you're not a sponsor, you've not been following it as close. I mostly share stuff, mostly with the collaborators, and then with the sponsors, and then everything else is sort of random. But if you want to stay up to date on Tractor stuff, which should be getting pretty cool this year, I recommend becoming a sponsor, supporting my work and open source stuff and all that. Okay, that's the end of that. We're going to get to Svelte now. Svelte.dev. Very kind of, I don't know, cybernetically enhanced web apps. What does that mean? Write less code, no virtual DOM. You know, that almost sounds like a bad thing. Truly reactive. Isn't React reactive? So this is basically a project that started, I think in 2016, but has only recently started to get more popular. It's already on version 3, which is kind of I feel like it's a pretty mature version at this point. And then what's interesting is there's really kind of 2 projects here. One is Svelte, and then the other is Svelte Kit. Fastest way to build Svelte apps. So just to kind of talk about the difference between these, Svelte is kind of like a React kind of component framework, even though it's totally different from React. Is the same sort of like core, you build components, whereas Svelte Kit is closer to like a Next.js. So it's a little bit geared towards actually building a site with routes and all this stuff. And so the interesting thing about Svelte is that it's trying to do as much as it can at compile time. And there's some interesting implications in that. So real quick, we're gonna watch 2 YouTube videos, a short one and a little bit longer one. The short one is basically a really quick intro. One of these channels on YouTube that I watch called Fireship that just kind of talks quick summaries of technologies. It's not bad. It's pretty good. So we'll watch the Svelte one.
Svelte. It's a JavaScript tool for building UI components, just like React, Angular, or Vue. But unlike its peers, which ship a JavaScript runtime to the browser to make your code work, Svelte is a compiler. It converts the declarative code that you love to write as a developer into imperative code that works with native browser APIs. As a result, you get highly performant code in a very small package. But most importantly, it's the only JavaScript framework that's actually enjoyable to use.
Wow, it's very nice.
We create components in .svelte files, which contain 3 main parts: a script for your JavaScript code, which can also be TypeScript, a style tag for your CSS, which can also use a preprocessor like Sass, and the main template represented as regular HTML. But it's no ordinary HTML. It's been empowered with all kinds of extra syntax for writing declarative code. Need reactive state? Simply define a variable with the let keyword, then reference it dynamically in the HTML using braces. If we want to change the state, we can do that by defining a function, then listen to an event in the DOM with on, and bind the function to it as the handler. Now when the value of that variable changes, the component will automatically re-render to show the updated state. In many cases, you'll need to run.
So that's pretty standard. It's not that different than a lot of things. And actually, it probably looks, with having this Svelte file and everything in one file, it probably reminds people of Vue, which I never was a huge fan of for various reasons. I kind of preferred the React kind of more pure JavaScript way to do stuff, even using JSX and stuff. And this is the first time I've really been like, you know what, this is worth doing things this way. So I'll let it continue.
Conditional logic or loops in your template. Instead of fighting against JavaScript functions, it empowers you with a syntax where you can clearly create an if-else statement or a for each loop when working with a list. Now when it comes to cross-component communication, Svelte provides multiple different strategies for sharing data between components. To pass data from a parent to child, you can use props by adding the export keyword to a variable. And now you can pass data into this component. And if you have a ton of props, you can use the spread syntax to keep your code looking fit and healthy. Now, for more complex component trees, you have a context API just like React. And if that wasn't enough, Svelte also has a really nice mechanism called stores, which are like observables that can be shared anywhere in the component tree and subscribed to in the template by putting a $sign in front of them. After you've built an awesome UI, you can then use the compiler to convert it to vanilla JavaScript. And if you're building a full-blown web application, you can use Svelte Kit to quickly implement server-side rendering, routing, and code splitting. This has been Svelte in 100 seconds. Hit the like button if you want to see more. Thanks for watching, and I will see you in the...
All right, so that was kind of a quick run through. We're gonna watch something else now. That's a little bit. Let me know if you have any questions. But we're gonna watch a somewhat recent talk by the Svelte author Richard Harris. So Richard Harris, I think he used to work at I forget where, New York Times or some major publication. Which is really interesting because that, for example, Django came from the same kind of thing. It was actually used in the real world, and it wasn't sort of like made just for it to exist. It was actually solving a real world problem that was used in production. And Svelte is very similar. He's also the author of Rollup, which I try and avoid most of the JavaScript ecosystem and using Node and stuff like that. But this is, if I understand correctly, Rollup is kind of an equivalent to Webpack. It might be a little bit simpler. And there's a lot of stuff in here. I don't like talking about these things because most of this stuff, it seems like really stupid. Like this is the kind of stuff in JavaScript that I hate. So we're not going to talk about it. But he is, I believe, an author of Rollup. And so he uses Rollup in Svelte. But anyway, this is him, and I'm putting this on a little faster playback speed so we can get through it faster. I'm not going to go through the whole talk, and I'm skipping the very beginning, but I think it's important to hear sort of the context and in the words of the author. Ooh, thank you for that follow. If you're watching on Twitch, you can follow me. If you're watching on YouTube, you can also subscribe or whatever the hell that is. So I love these because it sort of explains, if there's any new kinds of thinking behind a framework, which there often is, if it's worth switching to, and Svelte that is the case, then there's usually some kind of more fundamental concepts that you need to think about. And this is also great for people just to learn those kinds of things. A lot of people learn frameworks and learn programming without really getting into some of the more theoretical or kind of deeper architectural things. So I'm gonna play a lot of this video, and then let me know if you have any questions or comments along the way. And I might pause it throughout just to make comments myself. All right, so we're jumping in here with what is reactive programming. You all know what that is, right?
What is reactive programming? Well, as Michelle said yesterday, there are as many definitions of reactive programming as there are reactive programmers. So to make it simple, I just stole his from his slides. The essence of functional reactive programming is to specify the dynamic behavior of a value completely at the time of declaration. In other words, reactive programming is all about data flow. It's all about tracking values through your application. When a value changes, your application should react. We've talked about React a lot at this conference already, and we're going to talk about it a little bit more. React is a miracle. It changed everything. Whether you use it or not, you've probably been influenced by the patterns that React introduced to the web programming community. And since it was released in 2013, the React team has crushed it year after year, helping us solve problems that we didn't even know that we had. But I think we can do better. I think we can do a lot better, and this talk is going to be about how. Now, I know that in the JavaScript community, we tend to get a little bit uncomfortable when we criticize each other's work, especially when a React contributor is sitting right in front of me. Sorry, Brendan. But I think it's really important for our collective growth. And if you look back to the early days when React first came out and React advocates were giving talks at conferences, they were very, very critical about the frameworks of that era, and rightly so. I'm going to continue in that proud tradition.
I don't know what you're talking about.
React was the first library that used a virtual DOM, and we're going to talk about how virtual DOM libraries work. A lot of you might already know what this code does, but let's talk through it anyway.
So this is basically the standard of most web frameworks, React and stuff. This is how I prefer building kind of web applications, is using this kind of virtual DOM concept. React was kind of the first framework to really do this in a not to confuse with the shadow DOM, but the virtual DOM. There was kind of the first time. There were a lot of things that did this sort of React kind of thing back in the day, Dojo toolkit, but they didn't do it with the virtual DOM. So that was kind of an optimization trick that made React kind of work. And so now it's pretty common. It's kind of de facto way that a lot of frameworks work. Not every, and there's tons. There's way more than React, and there's countless options. But in terms of what's pretty mainstream and what I think I prefer. This is virtual DOM stuff.
Anyway, this is a simple React application that has a single component called app, and it has some local state, count and name. And it has two functions that change that state, handle click, which uses set count, and handle input, which uses set name. And then at the bottom, it returns a slice of virtual DOM. And as that state changes, that virtual DOM is regenerated each time, and then React's job is to reconcile what came before with what came after. So let's see what this process looks like. First, we look at the top level element. It was a div, it's still a div, so we keep it. Then we need to look at the attributes. It had a class name, app, it still has a class name, app, so we keep it. Then we look at the children. It had an H1, it still has an H1, so we keep it. Then we look what's inside the H1. Some text, it hasn't changed. We keep it. Look at the input. It's still an input. We keep it. The value hasn't changed. We keep it. Look at a button. It's still a button. We keep it. Its text has changed. So we need to apply that to the DOM. All that work to change a 4 to a 5. As engineers, we should be offended at all that inefficiency, but that's not...
And I don't know if he explained, but the concept of virtual DOM is just to model the DOM in a more lightweight way and make changes to that and make all your application code kind of work in that space. And then it uses that to rebuild the whole thing and looks and reconciles the difference between what's been rendered in the DOM and what's in your virtual DOM. And so it's basically, he's talking about it going through the whole tree to see what's changed, and then the things that have changed, it will update only those elements.
Not the bad part. The bad part is that we keep running this code over and over again. Every time there is any state change at all, we need to redeclare these functions that close over that local state. The problem here is that React doesn't have any understanding of the values flowing through your app. It treats it as a black box. In other words, by any reasonable definition of the word, React is not reactive. Or as John Lindquist said, React is a terrible name for React.js. So is the virtual DOM fast? No, it's not fast. Is the virtual DOM fast enough? Well, that's a more interesting question. I work with data visualization and animation, and I would say categorically, no, it is not. But you don't need to take my word for it. We can ask the React core team. The React core team don't think that the virtual DOM is fast enough, and I know this because they've given us things like should component update, react.pureComponent, use memo, and use callback. These are all abstraction leaks that let you, the programmer, tell the computer that it doesn't need to worry about this subtree within your application. In other words, you're doing the computer's job for it. Another sign that the virtual DOM isn't fast enough is when we start to develop amortization strategies like concurrent mode, which we'll talk about later. So a few years ago, I was thinking, what can we do about this? I want my users to have a fast application. I want them to have a good experience, but I want to have the experience of using a declarative component framework like React. And then it occurred to me, maybe we're thinking about frameworks all wrong. A framework doesn't need to be a thing that runs in the browser. Frameworks are not tools for organizing your code. They are tools for organizing your mind. So given that, maybe the framework should be a thing that runs in your build step instead. Or as Kyle was enthusiastically saying yesterday, compilers are the new frameworks. And so I started a project called Svelte. And this is what it does. It takes your declarative components and then it turns it into the efficient, imperative, low-level code that manipulates the DOM directly. The interesting part here is changed. How do we figure out what changed? Now, frameworks have solved this problem in different ways over the years. Old school React with classes had this.setState. You pass it some new state, it merges it with the old state, and it triggers a re-render. In modern React, we use hooks. We call the setCount function, and then it updates its counterpart, the count variable. In old school Svelte,
I hate hooks from an aesthetic standpoint because they're called hooks, but in any form of computing, they would not, conceptually, they don't really work like hooks. But so now they're teaching a whole generation of people what hooks are, and they're not really hooks in the way that most hooks are. This is coming from the source of webhooks.
Svelte, we had something very similar to classical React. This.set instead of this.setState. That also triggers a re-render. And that's fine, it works. But the trouble is, this.setState and this.set, they're kind of verbose. It's a lot of work to do just to update some state. The thing that they have in common, the problem that they have in common, is the this. As soon as your API depends on a this, you introduce all sorts of constraints that are a little bit difficult to anticipate at first. And so we wanted to improve upon that. Let's take a step back. How do we tell the computer something changed? Well, there's actually a really good answer for this already. We use an operator. Specifically, we use the assignment operator. We declare a variable, and then we say count equals count plus 1. Or more concisely, count plus equals 1. It's a good question.
This, by the way, what he's talking about is something that's actually, I believe, new in 3.0. Looking at the documentation, it looks like even up to 2.0, it was still using kind of React-style set way of telling the system that something has changed. So, and this is really great because this is really playing into the fact that this is a compiler. So anyway,
credit where it's due. Vue figured this out a long time ago. In Vue, you trigger updates by assigning to properties this.count plus equals 1. Now the way that that works at runtime is very different. It requires that you have a this, which has the problems that we were trying to avoid, so that won't work for us. Those are just the rules of JavaScript, but we're a compiler. We don't need to play by everyone else's rules. So we are days away from the release of version 3 of Svelte, or if you're watching this on YouTube, hopefully it has already been released. And Svelte 3 is different. Svelte 3 moves reactivity out of the component API and into the language. And I'm going to show you what that looks like. This is the same application as before, implemented in Svelte. Up here, let name equals world instead of useState, let count equals 0, and then we've got some similar functions, except this time we update this count variable by assigning to it count plus equals 1. And I can type in here, like that, click the button, and the application updates accordingly. And how does this work? We go to the compiled output and look at the code that the compiler has generated. We'll see that it's actually left our code more or less intact. It's just instrumented it with these calls to the invalidate function. Every time you assign to a variable that is used inside your component's markup, it calls invalidate. Invalidate's job is to say to the component, this value has changed, be aware of that when you update, and by the way, you need to update at the end of the event loop. We can actually get a little bit more efficient here. In Svelte, we don't need to use event handlers just to sync values between an input and a variable. We can use the bind directive, get rid of that, and we can make this an inline function. And get rid of that. And this continues to work as before. Now, an interesting thing about doing it this way, putting JavaScript in our HTML instead of putting HTML in our JavaScript, is that we can compile it to different outputs depending on the needs that we have.
This is where things get interesting, really kind of pushed me over the edge. You know, a lot of this is really cool, but again, I'm thinking, you know, that view style kind of single file thing, you know, it's interesting, but I don't know if I really want to deal with that, especially, you know, to me, that means that you need all this extra tooling. And again, I'm kind of contradicting myself in that, you know, with JavaScript, I'm trying to use as little JavaScript as possible, as little JavaScript tooling as possible, because I hate it all. I hate NPM, I hate Webpack, I hate it all. I think it was all stupid mistakes. JavaScript language, whatever, you know, I don't really care. It is what it is. But this kind of thing starts to get really interesting when you think about it from a compiler standpoint and how you can actually create different targets for different purposes. And there's basically, you know, as you can see, you can either generate for the DOM or generate for server-side rendering, which is becoming popular. I love the ability to have both options, right? I come from back in the day using PHP, and so, you know, all this kind of SSR stuff is really interesting to me, even though I don't do it most of the time. But the fact that if I could do it for free, easily like this, is very interesting. So in a way, Svelte was designed for this idea of DOM or SSR, or you know, there's a couple other ways you could use it.
So far, we've been looking at a JavaScript class that updates and manipulates the DOM, but we can also do server-side rendering. In SSR mode, all we're doing is concatenating a string, and this is orders of magnitude faster than creating a component tree and then serializing it. What this means is that if you do server-side rendering with Svelte, your AWS bills will be lower. Tell your product managers. How you use it, it's just like any other JavaScript module. You import it using the import keyword. Once your bundler is using the Svelte plugin, this gets converted on the fly into a JavaScript class. In the client, you just call new app, and then on the server, you have a different API because you're just serializing HTML. You call app.render. But we're not reactive yet, because in most components you will have state that is derived from other state, just like in our spreadsheet we have cells that are derived from other cells. And the way that this is dealt with in React is, well, they don't need to, because the code runs over and over again. So if we have a list of to-dos here that can be done or not done, and if we toggle them by clicking on them, and if we can hide the ones that we've done already, then we can generate that filtered list of hidden to-dos or unhidden to-dos using const filtered, and it will just regenerate that each time. And then down here at the bottom we have a list that maps over the filtered array. That's not ideal though, because we might have this component inside another component, which means that that filtered variable keep getting regenerated unnecessarily. Its dependencies might not have changed. So in React, what we do is we wrap that in useMemo, and we pass a second argument which the dependencies of filtered, in our case to-dos and hide done. And what useMemo does is it compares the variables in the second argument with the values in the previous run, and if they're unchanged, then it knows that the return value is unchanged, and it just gives you back the cached value. And that's a bit more efficient, but it's obviously more work for the developer. It's more boilerplate for us.
He actually started the talk, and I cut it just because I'm trying to make this go by quick. I won't. Wink, wink, maybe. That's kind of what this is about. This is Svelte. I'm trying to talk about Svelte, but also kind of understand it inside and out. With this stream, we'll kind of explore that. So one of the things that he's pointing out is that you end up having to use a lot of these kinds of extra optimizations in order to deal with kind of these common cases. He was talking about in the beginning spreadsheet systems. VisiCalc, is one of the first popular spreadsheets, and I think they invented the concept of the spreadsheet. And it was implemented in a kind of brute force way. It would, just like React, it would basically go through every cell and recalculate. Anytime anything changes, it would go through every cell and recalculate. And then it wasn't until Lotus 123 where it started creating a kind of dependency graph and only updating things that need to be updated. And so that's kind of, context for kind of what he's getting at is, and you can make the argument that you don't really need some of the performance, that computers are fast enough. It's fast enough to do a lot of this stuff over and over, and it obviously has been. When it scales, it doesn't necessarily. And if he can find a simpler model, which, it kind of has, that is faster and simpler, that's always a win.
If I zoom out so that we can see the entire React component, this is the Svelte equivalent. It's a little bit leaner. And this is something that we see quite a lot. I've converted a lot of React components to Svelte components, and typically what you find is the React component is about 40% larger. You have to type 40% more code to get it to work. But the trouble here is that this doesn't actually work, right? I'm clicking on these items, but they're not toggling. And that's because this code only runs once. Const filtered. It's a const, so it can't change. We need to find some way of telling Svelte that this is a reactive value that depends on other reactive values. And for that, we need to look for inspiration in the outside world. Speaking of inspiration, I find this guy pretty inspirational. Mike Bostock. He's the creator of D3 and is also the creator of Observable. Is anyone familiar with Observable here? Great. This is a hugely popular tool in the DataViz world. It's an interactive notebook generator, similar to RunKit or Jupyter in the Python world, things like that, except it has a key difference. Rather than running your notebook from top to bottom, it runs your code in what's called topological order. This is a fancy way of saying that if statement A depends on statement B will run first, regardless of the order in which they're declared. In other words, it functions like a spreadsheet. Well, we like spreadsheets. Maybe this is an idea that we could use in our components. There's a blog post I like by an Australian developer called Paul Stovell, What is Reactive Programming? And it tells the story of some code anthropologists from the year 2051 looking back and struggling to understand the code that we wrote today. Var A equals 10, var B equals A plus 1, A equals 11. Well, then we need to say B equals A plus 1 again. The relationship between those two variables isn't fixed. But in 2015, we have the destiny operator, var B destiny A plus 1. Now, if we change the value of A, the value of B changes with it. They are bound. It's explicit, a part of the language. Could we use the destiny operator in JavaScript? Well, no, we couldn't. It wouldn't be syntactically valid. And that would mean that we couldn't use parsers, we couldn't use linters, all of the other things that are really valuable. But it turns out there is a piece of syntax that we can use. And it's a piece of syntax that almost no one has ever encountered, let alone used. Does anyone recognize this? This is a thing called a labeled statement, and it doesn't really do anything most of the time in JavaScript. So we on the Svelte team have co-opted it. We've made it our own. $B equals A plus 1. B is now bound to the value of A plus 1. I'm the guy Kyle Simpson was trying to warn you about.
Doesn't have to be dollars. Just anything colon is apparently a labeled statement, and so they're using $sign as the label to indicate that this is, you're declaring something that is a bound declaration.
So we can add that to our original component. Just go down here to const filtered and change it to $filtered. Hey presto, it's reactive. That's kind of handy. And we can go further. We can say showing equals filtered.length and start to have reactive values that depend on other reactive values. Showing of to-dos.length. And then now, if I start to toggle these, it updates automatically. We're not limited to declarations. Thank you. We're not limited to declarations. We can also have arbitrary statements in here. So we can do this kind of thing, which is very useful for debugging values as they change. All right, so how does this work? Well, if we look at the JS output from this and scroll down to where it's updating the reactive values, it's taken these statements and it's wrapped them in if statements. If change.hide done or change.todos, then we recalculate filtered and we invalidate filtered. And you'll notice that because it's figured out that showing depends on filtered, it has to calculate filtered before it calculates showing. That's the topological ordering that Mike Bostock was talking about. And this is all extremely fast for the browser to run. This is very efficient code. Now, a lot of people, when they see this for the first time, they're like, I'm not sure about that. That's a little bit magical. And they don't mean magical in the good way. They mean the bad kind of magic. Evan Yo, the creator of Vue.js, said, well, this isn't even JavaScript. This is technically Svelte script. And he's right. We are abusing the language for fun and profit. But I find it a little bit odd that Evan, of all people, is the one saying this when he, perhaps more than anyone else, more even than Michel, has popularized the idea of assignments having side effects in JavaScript. The distinction that he draws is between magic that happens in the browser and magic that happens at compile time. I think this is an arbitrary distinction. I think if you draw a line between those two things, then you're guilty of making the same mistake as people who used to say that templates and styles and JavaScript should be in separate files even though they relate to the same component. What matters is the functionality, not where the functionality happens. Something I like to do when framework authors release benchmarks showing how fast their framework is, I add Svelte to it and then I tweet out the result. It's probably why I don't have many friends, but it's so worth it. Because look, this is an old one, and it's showing that Svelte, I really do urge you to do so. It's an incredible talk that really changed a lot of people's understanding about how this stuff works.
So he's going to make some points
So
about
start
how
typing into this input. This is React today. Now maybe you can't see what's going on here because you're in the audience, you're not typing. But for me, this is a very frustrating experience because my keys aren't having an immediate effect. I can't see the input taking place. So if we fire at the frustration meter and try it again, right, that's no fun. And a way that we have often tried to fix this is using a technique called debouncing. I can't type. Right, with debouncing, nothing happens until I stop typing, and then everything updates all in one go. And it means that the main thread stays unblocked and the app stays responsive, but we don't get any feedback, so that's not really a great user experience. Now, concurrent mode, or async mode, as it was referred to at the time, is the best of both worlds. The app updates while I type, but if it gets too much, then it will chunk up the work and yield back to the main thread. So the frustration meter stays green the whole time. But you might notice that as we get more and more complex, it starts to get a little bit slow to update the graph in the background. This is the same application implemented in Svelte. It's a very different user experience. I don't need to tell you whether that's better than the time slicing one. It's obvious what's better. And even in the frustration meter, I mean, you're welcome to. You'll probably get a better result than you do with React, but
you get the point.
Incremental gains.
Radical simplicity, a lot of stuff I'm into, these
Change
ideas.
what's happening. A few years ago, everyone was trying to put their code in web workers to unblock the main thread that way, but no one does that anymore because it turns out it just doesn't work. You can't move the code around into a different place and expect it to have a meaningfully different result. And the blog post boasted of best-in-class performance. Now, when you say best-in-class performance, it's like if you stand in front of a mirror and say Candyman 5 times. I will appear behind you. So I added Svelte to this benchmark, and sure enough, Svelte has better than... And they tried building the interface for these devices with React and with Vue and with a panoply of other frameworks, and they couldn't get
He's now
the
talking
results
about
that they
how,
wanted. It was just too slow.
Getting more to running stuff on the edge, running stuff on embedded devices, and all this stuff matters even more. Both latency and size of code and all that stuff. It's sort of like this basically improves everything. It's just kind of a different way of doing things. So, I mean, you could imagine this could actually open up a whole, genre of frameworks. And Svelte is, only one of the first, where it doesn't have to necessarily look exactly like this or be a single files or whatever, although it makes a lot of sense because it's compiled. Let's see if there's anything else in this. Oh, CSS stuff, kind of what you would expect, view style, scoped styles.
Who works on a web application that doesn't have any styling? No one. Okay, and then it applies that to
he also spends a lot of time, and this is interesting because he does a lot of visualizations. I think he made that app where he's typing and stuff. He's done some other stuff. Now he's working with 3JS and actually making a Svelte. It's called Svelte Cubed, which is basically 3JS wrapped with Svelte. So visual stuff is really important to him. He's also built in this whole kind of transition system, working with CSS transitions and doing custom transitions. It's really cool.
Literally just that. then the element doesn't disappear and reappear, it doesn't snap into place. Instead, it transitions out gracefully. This is really good for like notifications and things like that. And the way that that is done is just by adding this transition fly directive to the element and then giving it some arguments. It's an object literal with one property y. And that's just imported from this Svelte transition package here. Now if I toggle this really quickly, you can see that it actually reverses the transition smoothly and puts it back into the place where it's supposed to be, which is kind of difficult to do with some frameworks. Interestingly, though, this isn't done with JavaScript. When the state changes, Svelte will calculate a CSS animation, and then it will apply that to the element. Because CSS animations run off the main thread, this is more performant and more battery-friendly, particularly on mobile devices, than if you're doing the animation inside JavaScript. And we can get pretty funky.
Okay, that's the basic idea. He's mostly talking about transitions and styles and stuff, which is another part of it, which is pretty nice. But so let's look at what a little app looks like. I went to the this guy and I did this. It's pretty easy to get started. Despite having to use npm, I set it up. So this is kind of the Hello World app that you would get, and I'm going to use this here a little bit, but then for a lot of exploration, I'm going to use this basically interactive tutorial. Because it lets us kind of skip through around and kind of look at only the parts that are really relevant to whatever we're looking at. But just to give you an idea, if you wanted to use Svelte, this is kind of what it's like. You'd run those steps, you get a project like this, you wouldn't have a build directory. Of course, you'd have node modules with God knows what in it. And then, and of course, it's using rollup. So it sets us up with this main.js, which is basically setting up an app, which is basically, most of what Svelte is about the component model. An app is really just a way to sort of like take a component and then, mount it into your document. So it's sort of really just an entry point mechanism. Well, I thought there was a separate app concept, but it looks like this is directly using the app component here. So I guess setting it up is basically doing the mounting. So anyway, this is what a component looks like, a .svelte file. It's got script tag, it's got a style tag, and then any other kinds of tags, including their kind of templating system. Style kind of works as you would expect in terms of like view and stuff like that. So these are scoped to this component. Script is kind of interesting. So there's a couple of things. One is when you're making a component system, you need to have some concept of properties or the inputs. With React pure functions or whatever, it was really nice because it reduced it down to a function, which I love. I love anything that can reduce their conceptual primitive and map it directly to an existing programming primitive like a function. So if you can basically say, oh, this function is a component, that's really cool. It just happens to take whatever arguments. And React is not the only one. A lot of other component frameworks are able to do that with just a single function. And so oftentimes you end up getting past, props or something like that that has whatever the properties are passed in. In this case, we don't really do that. We just declare variables and we export them. So these are the properties for this. And by the way, all of this works with TypeScript as well, or rather he's got tooling that makes it work with TypeScript. A lot of the source for Svelte is in kind of transitionary TypeScript. Unfortunately, it's not all. How's the Svelte 3.js thing? It's called Svelte Cubed. Real quick. Svelte Cubed. Another thing, Vercel just hired Rich Harris. So, they're the ones that have popularized Next.js and all the cool stuff that's going on in the React world in terms of, whatever is hip now, server-side rendering or whatever. And they kind of see the potential of this as well. So they hired Rich Harris. And so that's, you can imagine I don't know if they're hedging their bets or this is kind of a long-term play, but anyway, he's at Vercel now. So that's cute. So anyway, TypeScript, this could be TypeScript. Svelte is mostly TypeScript. I thought we were going to be looking at a lot of TypeScript, but it's still a lot of JavaScript when we get into this Svelte source. So this kind of works like you would expect. You could, like you saw before, you could declare functions and, put those in as handlers in here and stuff like that. But yeah, it lets you export variables as properties, and I do like that. I like this idea that it's sort of modeling. Now in this case, instead of saying this function is a component, now we're saying this module is a component. Sort of, right? If you can think of this as a module, and you can kind of treat it as a module. Rollup and a lot of this Svelte stuff is made to kind of work with ES style imports and stuff like that. So it really kind of feels like you're defining a module. You just happen to be putting the source code in a script tag. There's some other interesting kind of benefits to doing this, and there's some talks and stuff that he's given on this style versus JSX, and I've gone back and forth on those things too. It's like I can go either way. There's certain reasons. It's sort of like whenever deciding these things, it's sort of like when enough of my values are aligned in one place, it's like, well, that's the answer. But if there's enough value in doing it another way, I will say, that's fine too, especially if it's done in a way that I can appreciate, which Svelte has done. So anyway, so we've created a component here, export name, so name is property, and we can just use that wherever. And then if apparently we're supposed to be able to just run, what was it? npm run dev. So this is where I was curious. So how fast is it, at least in dev mode? How fast does it pick up at changes and stuff like that? So here's our component. Here's our page. Here's our hello, visit, blah, 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 hello world, style. So we can change this to hi. It's pretty fast. It's not having to do a lot. And a lot of this is both the simplicity of Svelte and what it's doing. It's a little bit a roll up and how it does things faster than some other systems. But it's also because Svelte itself is designed to be compiled very quickly, not only because there's not a lot of code, but because it's kind of has built in sort of like, what would you call it, like tree shanking or something. Like it doesn't include the stuff that it doesn't need. And all of that. So I'm pretty impressed with how fast it's able to put this together. I know this is kind of at this level, it's hard to make comparisons, but it takes longer to compile the CSS than it does the JavaScript here. Okay, so that's interesting. The other interesting thing, maybe more interesting to me and kind of our purposes here, is actually seeing what did it produce. So if we go into public, first of all, we'll look at the HTML that it kind of set up as the host here. So we've got a page, and basically it just includes this script tag. So it's in build bundle. So this is the output that rollup included, that basically includes a little bit of what you'd call like a Svelte runtime. It includes a bunch of stuff, kind of helpers and stuff like that, that are used to basically do the operations. You're not even really including Svelte as a library. Svelte is not a library. I mean, you could arguably say that this is a library that it's including, but it's kind of just generating this code for you. And there's not a lot of it. Pretty quickly, we get to this sort of base Svelte component. And then we get to the R component. So let's see what the rest of this is. I think the rest of this is, let's see, app. Okay, so this is kind of the kind of a wrapper around the core stuff. So yeah, this is all, the rest of this is all for the component. So it's only, a couple hundred lines of JavaScript that it's putting on your page in order to do basic stuff. Obviously, it's going to include more if you're going to do more things. If you're doing any of that stuff with animations and transitions, it's going to include more code. but sort of baseline, you know, it's only including what you use of the system, which is a nice thing about compilers. So the runtime is very simple, and it's probably worth even looking at some of this. You know, we've got a no-op, let's see, add location. I don't know what the hell that's about. Run, that's kind of a weird helper. Blank object, there's a lot of weird helpers. I don't know what that's all about. You know, what I think it is actually just like this actually simplifies the code later on. It's less code. When you're trying to make the minimal, you know, maybe not this, but I don't know. So there's some state management, you know, because it's basically going to be using events and stuff, trigger updates, and it's going to basically queue up those updates. And so it has a kind of update scheduler, so it queues stuff up and then applies them. Flush, what is this? Flush calls, callbacks in this order. So this might even be a generic thing, but I think this is what, you know, this is obviously what it's used to apply the changes. Going through dirty components, set the current component, update the component, so that's going to go and do stuff. Unset the current component, binding callbacks. So if there's any binding callbacks, we're going to call whatever it needs to call in a loop. Yeah, a lot of this is sort of like what you know, a lot of these callbacks are the updates that need to be made. The operations of like updating the DOM and stuff like that. So there's certain things that are done in certain order, which is described here, which I'm not going to get into right now. Update, mount component. It's really interesting. It's very kind of functional, or almost procedural kind of code. It's still very JavaScript. We're gonna be looking at a lot of code, so instance, that's interesting. I've already kind of gone through it a little bit, so this is, I'm just trying to give you a sense of kind of what it's producing, give you a chance to kind of read it quickly, and like you don't have to like fully understand it, but kind of get a sense of what it's doing. So, you know, the bulk of it, init, you know, mounting, stuff like that, and then it's all just callbacks being called in a certain order. We've got this kind of like Svelte base component that basically lets you, has sort of these built-in, basically these things that a component can do is you can, you know, set properties, right? Change its state, handle an event, or destroy the component. A bunch of interesting dev stuff. If we weren't in dev mode, these wouldn't be here, but in fact, I'm not entirely sure. Okay, these are just wrapping these appends and stuff. It's kind of neat. When I saw this, I was like, oh, that's interesting. So when it's doing these operations like inserting a DOM element, appending a DOM element, detaching, in dev mode, it actually dispatches custom events, which is kind of neat for debugging this sort of thing. Validate slots. So we're going to look at the documentation soon to get a better sense of kind of like what are all the concepts in Svelte, just to kind of map them out so that we can then, when we're looking at code, better map them to understand what they mean, what they're doing. It looks like if we're in dev mode, we wrap Svelte component to do some more stuff here. I don't know if these are hooks or what. And then we get into this. So this is where it gets, this is where it's interesting. So all of that so far, whatever that's plumbing, you know, there's not a lot of it. It's all pretty straightforward. Like you kind of have to like read it to really understand it. But it's not a lot. It's not complicated. We're also, and if you look at this, it kind of has almost like what's nice is that this was readable too. You know, it didn't try and minify and obfuscate it. I'm sure you could turn that stuff on, but what's cool is that this is still like relatively readable. but they're still taking like these kinds of shortcuts and stuff. So how is a component modeled in the compiled code, the code that actually runs in the browser? So that's what the rest of this is. It's really interesting that there's, I don't know if this is going to be defined for every component, because like this it doesn't seem like it's scoped. So it'd be interesting if we add another component, what it'll do. But this create fragment is basically, the part that's actually going to create the component in the DOM. You can kind of see here that we have const block. Why do we do black? Because we dispatch dev. So ultimately returning block, but it looks like in dev mode we pass block to some dispatch event thing. So but this block object has, and they're using these shorthands, C maybe for create, L, I don't know what that is, M mount. It's nice that they have these. I don't know if in dev mode that these would be here named this way, but it's nice that they are. P update, I guess. D destroy. So you can see, so for this element, it's also interesting how they did this. They're declaring a bunch of variables up front, and then in create they're assigning to them, and then these are, I'm actually kind of curious where, let's see, text. Do we have like text up here somewhere? Because it should all just be in here. But right, I don't know. Did anybody see like text? Maybe it was it passed in like a closure or something, some kind of argument. It's a little hard to kind of see some of the scoping in here. Create fragment. Huh, that's super interesting. So I don't know where those are coming from. In theory, we should be able to... Oh, that's that. Oh, that's this. They totally went by them. They're so quick. Yeah, these are basically like create element, remove child, create text node. So just a quick shorthand, putting them in these variables, applying, whatever. So basically, the code that you write in this Svelte file isn't real code. It's not going to run this code. It's actually going to parse this and put it in an intermediary kind of structure, and then it's going to generate this code. And by doing that, it's able to kind of do it in a sort of optimized way here. Mount, it's going to append put everything together. So you can see it's like it's sort of generating DOM manipulation code. It's very different than creating a virtual DOM structure and then doing a complex reconciliation where you walk the current DOM and walk the virtual DOM and try and see what's different and keep track of what's changed and stuff like that. Okay, so that was create. And then there's instance. So this is interesting, and this is specific to this component. Again, it's kind of hard to tell because it's not scoped. This seems like maybe it's part of the runtime or something. But this is specifically for, and maybe this is actually create fragment. Maybe if I did another component, it would actually do a bunch of stuff in here. Like it would just kind of generate one big component. I don't know, but this is where the logic of your script code comes in, right? So you're going to find the code that you write in script in that. So if we did function foo, it looks like it threw foo in here outside of instance, but which is interesting, right? I haven't tried this before. So there's a concept of slots. We'll see all this in the documentation. Validate slots. And it's doing all this stuff in order. So set props, if name, props, invalidate. So the whole kind of like in React and in old Svelte, you'd have to call set. And so set is basically saying, I'm going to set this variable and, hey, notify the system that things need to be re-rendered. Really, that's the same thing as saying just do the assign it and then run a function saying, hey, things changed. And you can even say, this is what changed. And that's kind of what this invalidate stuff is, which again, you don't write. It knows based on assignment. If we were to do assignment in here, like name equals foo now. Yeah, look, now that it knows that we're doing assignment in that function, it put that function inside instance. And then it's doing the assignment inline in the call to invalidate. So, I mean, that's the kind of thing that you can do as a compiler, right? You can say, oh, well, assignment is when state changes happen. So why don't we just instrument assignments? And so that's almost literally what it's doing. It's wrapping or, adding some code or anytime there's an assignment that is relevant and needs to trigger something. So I imagine 0 is just some index, so it's the 0 property or whatever, I don't know. But then he talks about kind of the complexity of like, well, now you know, if you want to do something like, let's see, what would it have been? We could do, we don't necessarily have to export it, I think, if we were to just say like foo, and then say foo equals name plus foo. I don't know. It's not happy with that. No, wait, what am I trying to do here? If I do an export, that's a property. I don't know exactly what I'm trying to do here. What's his example? So this is kind of the cool thing. So something changed. So we do just showing as a variable. Maybe I want to do a let here. Can't tell if it's unhappy with me because I'm not doing something like I've never written Svelte before, so I can't tell if I'm just doing something that's stupid. It might have to do with
So we can add that to Presto, it's reactive. That's kind of handy. And we can go further. We to const filtered and change it to $filtered. Hey Presto, it's reactive.
So he's not even doing a let. We're just doing an assignment. That's interesting. Okay. So they're and again, this is a compiler. Svelte is going in and saying, oh hey, this is a declaration that's prepended and is reactive. So any assignments in here, we're going to treat a certain way. So this then gives us, if we were to update name, I guess it's complete because we also have a foo function. Let me just do that so it's not super confused. So if we set name, it's going to invalidate name. Inject state, I don't know if this is kind of debug stuff. But then ultimately we have this here where the updates, and it will basically do very kind of like declarative, or not declarative, but imperative style operation. That's what's interesting about this. It's sort of like we're defining things declaratively, and then it's producing some very optimized, it just like, assembly or something, it's producing much more imperative style code. which is, very simple and stuff. And it's basically the code that you would have to write if you didn't do things declaratively, but you don't have to think about it because that's what compiler does. It lets you writes code for you. So if we were to do other stuff that then depends on foo, it would do that in a different order here. But it looks like that's where all those kinds of like dependent update stuff happen here. And then we saw that init thing above. So this is kind of creating the actual app component as a class here. And we're initializing it, giving it that crazy create fragment thing. We're creating an event for debugging stuff. Has a name. That's pretty much it. It's basically extending Svelte component. And then we use it. What's cool, what's interesting is I believe there's a mode and it's built in where you can actually have it automatically register these as custom elements, which is really cool. And start using Svelte to basically compile to web components. So that's another cool thing about this compiling thing, is that we don't have to generate code that's gonna, well, if we want web components, we would generate something that does modify the DOM and then wrap it with a web component. But then as you'll, let's see, you didn't really talk about it too much, but if we wanted to do server-side stuff, kind of the first thing that a lot of people would do with server-side rendering is to say, well, let's just implement a DOM, a virtual DOM, and then render that on the server side and, serialize that DOM representation and then output that as text, as, whatever, HTML or whatever it's sending over the wire. Here, it can kind of skip that step and just go directly to concatenating, a bunch of strings to produce that HTML output or whatever. So we're not seeing that here. I don't really want to get into that, but that's the cool thing. The other thing that means is, so one of the things that you learn when you start doing server-side stuff and your components, and it's really interesting when you're using something like React to declare all your components, and you're, writing some JavaScript files, you can kind of just use window. You can use these globals that you expect in the browser environment. But if you're going to do server-side stuff, you really can't unless, they've produced some way to emulate window, which they probably do, but then it's not going to do what you think and yada, yada, yada. So a lot of the time you end up having to write your code differently to make sure you're not using certain globals and stuff like that, which you should already not be using them, but, in the real world, you end up taking certain shortcuts and stuff like that. So for a lot of people, when they transition to starting doing server-side rendering stuff, they have to go through all of their JavaScript code, all their components to make sure they're not doing anything like that. And it's kind of the same thing going on here. Normally when I think of a component, I think this is going to be executing in the browser, but we have to remember that this code is not actually being executed in the browser. This code isn't even being executed at all. It is being parsed and then reassembled in a totally different form. So we're not really running this code. We're like running snippets of it here and there, but it's basically being taken apart and put together again. Which means, we actually can't really use window here. I don't really know what happens if you did use window in here. But that's kind of another thing, is you're doing things this Svelte way. It's like, okay, we need to make sure that you're not calling window and these are the globals and stuff. So that kind of gives you an idea a little bit, sort of the first step of like how it works. There's, and again, this stream is more for me than you, so if I'm going too slow or whatever, or too fast, or talking about uninteresting things, feel free to let me know. But, really I'm prioritizing myself and learning here. I've only gone into this a little bit earlier today. I've never really worked with Svelte before, so this is basically new to me. Conceptually, it's all, whatever. But so Svelte has this pretty cool tutorial, interactive tutorial thing. And it's a little bit easier to use than, an app like this. I wanted to do this so I could see, what does it actually produce? How is it actually sort of set up on the page? What does the bundle look like? What is the code that produced? When you use this interactive tutorial and you create, some kind of component here, it's great, you know, it updates as you type and all of this stuff. When you look at the JS output, it's actually only showing us that minimal bit, like the end of the file, and even a smaller amount because it's such simpler component. But I like this because you can kind of now see what is the minimum needed to produce certain things. So like if you want just a component that has an H1 tag, like this is the minimal amount of code that it would produce. This is what it would put at the end of that file. Way less code than we even have because we have script tags and style stuff. So you can see how, again, it's just like creating very optimized stuff here, but also means it's very easy to understand. We can kind of look at it. We've already gone through this on ours, and we can look at this one and see, oh, it's basically doing the same thing, creating H1 element, setting its text content. This is the mounting code. It's going to insert, you know, whatever these callbacks are. It's not doing anything. Detaching, detaches. Right? So this is a simple component. That's really cool. So there's actually a ton of stuff in here. And I was going to go through not all of this, but to go through some of it just to kind of get a feel for it, while also looking at the JS output just to get a sense of like what it's doing, how it's doing it. If you were making your own Svelte, this is the important stuff, like, you know, because you're not, I mean, obviously you need these kind of like helper things or whatever, but what I learned looking at the Svelte code, it's mostly a compiler. Compiler is very simple. And then it's outputting this stuff. So when you're thinking about like how do you create a Svelte-like system, you're just learning how to create ways to output this kind of code. So by going through these kind of different things, we can kind of see what kind of code it's generating to get a better sense of how that works. Because it turns out, you know, I was going into this thinking we were going to look at a lot of the source code for Svelte, the early versions and all that stuff. It's not that interesting, and most of it's pretty boring compiler, parser stuff. We'll still look at it, but turns out this is the more interesting stuff. So we've already done this. Let's do dynamic attributes. No, let's do styling, nested components. Yeah, let's see what happens when we do this. So we don't actually have to do this. We can just do this and it'll write it for us. So here there's another file component with a paragraph tag. We can import it. It's nice ES6 import. And then we can just use it here. The cool thing is when you start using web components or turn on custom elements or whatever, is like that. This is what you would write in your HTML as well. So that's kind of cool. So we're doing a little bit more. We're doing some style stuff. So let's see what's different here. This is the first time I've seen code that's using, you know, another component. But it looks like, you know, because all the components are just classes, it's just creating another instance of that here. We've got our P. T, I guess, for text. Create component. So that's interesting. Nested. This is a look at the data structure inside. I don't know what this is. This is like an internal data structure that the components have. You know, I haven't quite understood like what goes in there. Another interesting thing, reading the source code, it can be a little hard to tell what's compiler code and what's code that's going to be used in the output, which is a little frustrating to me. Which is why if this was written in another language, for example, Go or Rust or whatever, it'd be much easier to see what code is code that's going to be put in what you might call the runtime versus the code that's in the compiler. Setting attributes. Mounting, mount component. Current true is interesting. How that's used. If current return. Transition in. Oh, in and out. These are transition hooks. That's interesting. And I guess we're not doing any transitions, but because our nested component might be, I guess it's just putting these in here just in case. So that current stuff must have to do with the these transition hooks, which I'm assuming I and O is in and out. Right, order of this stuff matters. It's all taken care of. Okay, cool. What else? So one thing that kind of bothered me about this Svelte stuff is its templating stuff, but we'll get there in a little bit. Making an app. Let's see, what do they have to say about this? Svelte components combine a trans component to a regular JavaScript class and new. So they're just saying, yeah. All right, so here we're getting into the reactivity stuff. Kind of the stuff that we're playing with in my project, but now we have a on-click handler. It's interesting that they're using, it's interesting like JSX and React. You just say on-click, which is also the attribute for setting a handler in HTML in the DOM. Here they decided to introduce, which is very kind of Vue inspired, but they're using a colon here. But so what I expect to see here is kind of the same thing we saw before. Increment count is now put in like instance or something. It's interesting, we haven't seen instance so far because we haven't really done any JavaScript stuff in the previous examples. So again, this instance function is something that it produces to create its version of our script code. You can see the let count. It's pretty much exactly how it is. Increment count as an assignment, so it's wrapping it with an invalidate. So now I'm kind of curious, what is instance returning and why? Right? It's like, okay, properties, but also functions. I don't know. So declarations. So this is what it's calling automatically updates your change. So this is the part, that's kind of where some of the magic of the optimization of true reactive programming is. We're declaring these bindings. We're saying that doubled is always count times 2. And so if count changes, as you can see, because we have that invalidate function, we can just say, oh, when we've invalidated count, let's also invalidate anything that depends on count, like doubled. Declarations. Interesting that they're calling it declarations. Let's see if there's anything interesting to learn in the JS output. Look at this. If not mounted, dispose, listen, button, click. I was looking at the source code for Mithril, which is what I normally use, which is a kind of a lightweight React, even simpler than Preact, so it's smaller, simpler. Still mess of code because it's got to work with all of the DOM and deal with, did any of the event handlers change? We got to keep the event handlers stored somewhere, and then if they're, reassign them or whatever. Like reconciling DOM is a messy business. Like the DOM is not a simple data model. And so they've got kind of, stuff going on here, but it's way simpler than any reconciliation code that I've read. I forget what P is supposed to be about. Update. If dirty and. I wonder what that's all about. Dirty and 1. Oh, this is a bitwise operation. Okay, so this is actually including. Oh, that's really interesting. Wow, that's crazy. So they're including the properties, I guess, that have been changed in here. So if count has been updated, set the data for count. I don't know what a context is, but I just assume that that's data going somewhere. But because double depends on count, it's also saying I don't know what's going on here. And it's not, we're not gonna not find code that's hard to read in here. But overall, it is much simpler. From a code standpoint, like this is still hard to reason about, but that's the whole point. It's being generated for us, but trying to reverse engineer it here. So here because we have that declaration, we have this kind of self that's coming in here. Self, so maybe this is the component instance. And again, this is that internal data structure. And then this is an update callback. And we're telling it if counts dirty has been changed. Run this code. It's actually interesting that they leave the label syntax in there. I guess it doesn't hurt. But then, yeah, invalidate doubled. Statements. Oh, so this is a declaration. So that's interesting. You can put a whole block in a declaration thing. You can do if statements. Let's see what happens here. This is really interesting. This isn't, I call this a statement. Let's see, so these are like a reactive declaration and a reactive statement. This is interesting because doing something like this is basically defining a rule, right? You're saying if count is ever equal to or greater than 10, set it back to 9. So that's really interesting. Using this as a way to basically declare rules or constraints. I didn't know you could do that. I wonder if there's anything that it does differently in this case. Nope, it's just running that code, which makes sense, right? Okay, what is this? It's because Svelte's reactivity is triggered by assignments using array methods like push and splice won't automatically cause updates. One way to fix that is to add an assignment that would otherwise be redundant. Okay, that's like a hint. That's... yeah. Kind of treating it like it's immutable. So that's interesting. Special case for objects and arrays. Really, any mutable data type. But it's interesting they've come up with these conventions, which is funny. This is how you append in Go. Assignments to properties of arrays and objects work the same way as assignments to values themselves. Right, because there is an assignment, so I guess it's just how it normally is. Simple rule of thumb, the name of the updated variable. Food bar won't trigger reactivity on Okay, so that's interesting. This is the sort of thing that you would expect. There's these edge cases where you're like, what? They might come up with something to improve this later, but that seems like a silly kind of pattern. But it's also not, you know, like if you're going to do something to trigger the compiler to know that the value's changed, like it's a reasonable, more or less a no-op. You know, I wonder if it even, I wonder if we did that, if it would remove that code, because it is a no-op, but it's what it would need to do it. Probably not. I'm guessing not. Oh, interesting. Yeah, it does just replace it with, well, I guess because it's doing this thing where it's putting the assignment in the argument for invalidate, that that it doesn't look that weird once it ends up like that. Okay. Declaring properties, we've seen this, we just export stuff. We can easily specify default values for props like you would expect any other thing. That's great. And if this is TypeScript, you know they'd be typed because you can just declare the type. Properties, you'd spread them onto a component as you'd hope you could do. You need to reference all the props that were passed into a component, including the ones that weren't declared with export. There's these interesting globals, like internal variables that you can use that are really interesting, which I'm assuming are actually just the value of, right? Because they're being executed in the context of this instance. So maybe it passes props if you use it. I don't know. That's interesting. But, you know, we're seeing over repetition, we're seeing sort of the structure of how they're doing this, right? They're creating this sort of like DOM creator callback called create fragment, you know, that has some generated callbacks, lifecycle things. And then it has a function that is basically the execution environment for the code in our component. And then we wrap it up in a nice class. All right, now this stuff. So I'm trying to remember where I first saw this kind of thing. I mean, I guess it makes me think of mustache, right? In fact, it might be valid mustache. Which you would imagine is the inspiration, because they're not going to put necessarily logic in there. Where's like a... variables. Yeah. It's very mustache inspired. So if somebody, you know, if they're going to be doing this sort of stuff and creating these things, there's, you know, a way you can kind of do this. Now this feels like, I mean, it is opening up a kind of expression, and so we know that if we open that up, there's going to be some JavaScript code that we can have in here. But then obviously these kind of opening and closing tags are not valid JavaScript, so this is now a custom thing, and this is a compiled system, so you can kind of do whatever you want, right? But from a design standpoint, I almost feel like if you could collapse that down so there isn't a new concept, a new thing. Basically, what I'm trying to get to eventually is Genshi styled templating, which is a Python thing, but it's not used that much. I don't know if there's probably, the JavaScript world has recreated everything over and over again, so there's probably something like this in the JavaScript world. But what was interesting about Genshi is that it was a template language that was well-formed XML. And it's like, who cares, whatever, XML. But still, it's like from a standpoint of just like, I don't know, consistency and, like parsers. When I installed, when I set this up, I had to install an extension to VS Code so that this would be syntax highlighted properly, especially if it was going to have that, templating syntax in here. If it was already valid XML, like it would just work. So that's kind of one of those things where it's like, maybe they could have, so you can see, like, if you want to do a for loop, you create one element and then give it the loop, and then it's going to recreate that element with the instance in the body. So you still have some kind of variable, for text, but a lot of the structural stuff, like I think there's an if, an if. If anybody's seen anything else like this, let me know, because I like collecting examples of this. But an if statement is the other common one. Where is it? Template directive, actual template. If I were to go down the JavaScript framework rabbit hole now, I'd definitely try Svelte first. I wish it were an executable instead of an npm package, though. I hear you. That's what I'm doing this for. I'm glad there's people that just also agree. I mean, I guess Bank of Money, you've been watching my stuff for a while, so you probably get what I'm putting out there. But so here's an example of an if. It's a little weird because it's putting it on the element that might be conditional. So it's like, okay, if it was false, then we're not going to render this element at all. But it kind of makes sense. You're putting the conditional on the element. But it means that now you kind of have to like have an element to put the if on, and so you might be creating elements that you didn't need otherwise. But it looks like it supports these kind of like pure conditional things, which is also kind of cool. Choose, well, that's interesting. It kind of has like a switch. Obviously loops, we saw loops. And really, that's the core stuff. There's a couple other directives in Svelte that are interesting. So obviously, if statements, you can do if else. This is their else syntax. Else if syntax. This is their looping syntax. The templating is the one thing I did not like about Svelte when I tried it. Yeah, again, first thing, I felt like it's just like, it's fine. I'm not like, I hate it. I would probably use it, but, because it is basically Mustache, which is sort of like the most lightweight templating kind of syntax you can use. So, but it seems just unnecessary. Like I feel like they could do a Genshi style thing here. But some of the other features that they have, so keyed each blocks. Add remove to the end. Okay, so this is kind of a looping, gets into why you put keys on things. And the thing I like about React JSX is so good with conditionals is yeah, it's JavaScript, right? JSX, when you're doing all that stuff, it's just JavaScript. Which, it's interesting because it's like, why don't they just make kind of like the JSX, just have JavaScript execute in these? Like, you're already, they're kind of creating a new syntax, which is a little bothersome. Why not just have open squiggly brace and it's JavaScript? I guess part of it is now you have to deal with things like, well, an if statement is going to have its own curly braces, and then how do you close that and stuff like that. It is kind of weird when you need to like go in and out of a different thing. And so the fact that JSX is just can coexist with JavaScript, kind of simplifies that. So anything else all of a sudden becomes a little bit harder. But did Vue do this? I don't use Vue, so I could be okay, they do that. Okay, so I'm sure somebody should have said Vue, but literally this is what Vue does. So Genshi or Vue style, I was so happy to see this in Vue. It was one of the cool things about Vue, but a lot of other things I just like Vue. I actually like Vue just fine. It's just that like momentum of React and everything. But yeah, very Genshi inspired, sort of simplified. Doesn't really care. It's modernized, right? This is creating valid, back when they were doing XML, this is an XML template language. And, back when they were talking about XSLT, like nobody cares about that. Here it's using modern HTML, custom attributes, which is cool. So it's interesting. I'm surprised, given the influence that Vue has had on Svelte, why they didn't do this for their templating. Yeah, we'll see. Maybe they don't have it in here. Oh, they have the await blocks here. So this is cool, but I can still imagine a version of this. Well, I guess there's these different blocks, right? So in Vue, how do you deal with like if else? So you can do expressions, which again is kind of the JSX, like just do JavaScript. But then if, so then how do you do like an if else? Right? That might be part of the reason, is because once you do this, you're tied to the structure of an element, which is, a monolithic thing. You can't be like open tag, close tag, open tag, and it be the same thing. Because I'm not seeing any examples of like an if else. I guess you could kind of just be like, have another if that is the inverse. Is this a real thing? What is going on here? Why didn't I see that in the docs? Where's like their list of directives? Why isn't this like, this doesn't feel like a reference. Weird. They did go a little too far with this shit though. It bothers me. I don't know why. It's one of those things where it's just like, from a design standpoint, oh, you have a full syntax and then you have a shorthand. Well, nobody's ever going to use the full syntax then, so you might as well just make it the shorthand. And so then that bothers me. But like, this just kind of feels weird. So I don't know what's going on with the else. Like, is this real? Does anybody know this? Maybe this is old or something. I don't know, I'm seeing this, but I don't know if this is like old or it's just undocumented or what. It does seem weird though, because it's a different element, and so, you know, conceptually, you're modeling it as like these two things are connected, but everything else about them, they're totally separate. Anyway, I don't want to get too hung up on this, but I'm like, 2020. I mean, I don't know, but you know, I don't love this, and so that's one argument against doing it this way. What did Genshi do? If they have this kind of outer thing. You choose. Do they have an else syntax? Thank you. Essentials. What was I looking at? Template syntax, conditional rendering. Okay. I guess else if is new. Yeah, I don't know. I'm not seeing an else in Genshi though. It's almost as if that's why they created choose, so they could do this. But this is kind of doing the same thing, only it's nested. You'd have an outer choose. Yeah, I don't know if I love that better. But whatever. So, you know, I'm starting to get a sense of why they would go with a kind of traditional whatever syntax in Svelte. But anyway, yeah, some of these things like a wait is really cool. Like a native promise support for like, oh, it hasn't happened yet. So you render this. And then when it does resolve, then render this. Or if there's an error, like this is a cool feature. So we haven't really looked at the code for that. Let's go back to the basic if blocks and see how the code is generated for this. Look at this. It's got a whole like create if block. So it's almost like it's doing. Oh, wow. .c. So it's basically creating another create fragment for each case. In this case, there's only one case. I don't know. How does this work? I guess it knows that there's basically a default case and then a special case. So it's creating a case for that. And then I like this. It's sort of composing, calling to it. It's the same structure, so it's also C. And then, of course, you have the if, because it's an if statement. That's interesting. What about loops? Get each context. Ah, I see. So it's creating a separate fragment block. So because they use fragments, well, they use blocks and fragments a lot in the source. So, but basically, a block is a fragment-ish. Oh, I was at version 3. Oh, that's interesting. So you're saying maybe they took it out. That would make sense. They're like, man, this is weird. Let's take it out. But this is interesting. So it's got a block, and then they've encapsulated kind of the iterator as this context that it passes in. I feel like with just this, like you could reverse engineer Svelte and not even read the source code, which is cool. Also kind of why I'm doing this. So, and then it has an actual loop. Create each block. And then we get a list. Interesting. Very interesting. All right, so what about keyed blocks? So this is just having a key included. There's also a Svelte feature for called key, and I feel like this should have been named like watch or something like that, but it's basically if the value changes, then it will recreate this. Does anybody have any idea why they would call it key though? Especially when you have the concept of keys as a unique identifier for list elements. It's a little confusing. You'd think key, does this have to do with like loops? No. No peace, no peace. Glad to see you back, Jeff. Thank you. I'm actually, you know, for YouTube viewers, I have not been gone. I've just been mostly doing my daily streams on Twitch. And because it's kind of like a special event, I feel like it's sort of educational and you know, I want more people to know about Svelte. I'm doing this as kind of like a special event across streams. But I think I'm going to be posting to YouTube more again soon. But thanks for coming by and watching. Okay. Events. It's actually kind of funny. I mean, other than implementing these things that it's importing, you could almost use these as tests to create a Svelte alternative. On mouse move MX. So that's interesting. Not only can you listen to the event, but you can get access to the event in the block? Oh no, they're creating M as a global, or a whatever, component property. Is there anything interesting about this? I guess not. It is really just... Actually, how class? So here's their style stuff being applied. But send mouse move. Huh. Nothing particularly interesting here, but I'm a little confused. Oh. The events aren't attached until it's mounted. So, what does it need dispose for? But they've got their listen for events. I don't know what that is. Context one. I guess it's in there. Oh, wait a minute. Context 1, 0, 1, mouse move. That's what we're returning from instance. Look at that. It's returning a context. So context 1 refers to the return of instance, which is our function handler. That's interesting. And I ate before the stream and now I'm hungry again. Inline handlers are nice. Is there really anything different here? They're anonymous. So that looks like they just name them. Yep. That's event modifiers. This is interesting. This is one of those features where I'm like, eh. You can do modifiers on events. Which is like, yeah, these are helpful, but are they necessary? And I suspect... Where is it? Oh, it looks like they're just options in this listen nonsense. yeah, everything else is the same, so it's not interesting. Component events. This is interesting that your component, and again, very cool if you're thinking about, you know, compiling to web components or something. Well, it's interesting you have to create an event dispatcher. I guess because it's for that component, right? So let's see how this works. Because you can have the inner thing. Just show me the code. Don't make me write it. Dispatch message. And then we have inner, we can have a handler on that event. So it looks like we're saying on inner. Yep. I'm really curious to get a better sense of this internal data structure. Okay. Event forwarding. Components events don't bubble. If you listen to an event, it must be forwarded. So there's certain things like this though where it's sort of like it's extra work that you have to do because it's compiled. Whereas, you know, in React or something, you would just dispatch a custom event or something. I don't know. Okay, so that's basically to forward it. Oh boy, bindings. Top down, that's fine. Useful to break that rule. Could add on input event handler that sets name. So this is what's interesting because this is very kind of unreact, is doing two-way data bindings. But it seems to be a specific case for input fields. But you can imagine what it's doing is just generating that input handler. So the DOM, everything's a string. With bind value, it takes care of it for you. Bind value versus, oh no, it's still bind value. What the fuck happened to the valid attribute? It's supposed to be quotes around them. Maybe this is all new and it was written by somebody else. Group inputs. All right, this is getting crazy. Bind inner HTML, that's cool. Assuming you can rely on content editable, which usually can't. Each block bindings. Yeah, whatever. Blah, 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 lifecycle. So it's interesting, these are basically done as like hooks. So you'd say on mount and then you'd give it something and it'll basically, I'm guessing, put that in the on mount, right? create each block. Wait, what is all this other stuff? I just want the on mount. It's got loops. Huh. That's crazy. I would have thought it would be a compiled, statically insert that into its lifecycle, but I guess it's just a hook function that registers a hook, and so they just pass that along. Doesn't really do anything special in the code that it generates. I imagine these are the same. Maybe. On interval. The fuck is on interval? On interval. It's important to call lifecycle functions during the component's initialization. It doesn't matter where you call them from. I see. This code is run once. Anything you put in the script tag is basically run once on initialization. So if you were to do something like set interval, you usually want to clear the interval if it's destroyed, and so they made a helper that will do that so that you can just do on interval. Okay, it's fine. All right, so I'm not going to get into motion or transitions. Like, that stuff is really cool and interesting. Or animations. Actions are kind of weird. They're like lifecycle hooks, sort of, but called actions instead. But it's kind of cool. They're kind of like middleware, lifecycle middleware. It's interesting. You write them using DOM and not some custom API thing. But I imagine it doesn't change this much. Probably just. Oh, there's all this other stuff going on. Click outside. Action destroyer. Click outside. There it is. I see. Click outside call. And that cleans it up, I guess. So otherwise, what is this class directive? Oh, that's just another kind of syntactic sugar thing. Shorthand for class. Slots make sense. So if you wanted to have something with its inner, an element, a component with a, what would you call it in React? I guess just it's children, but you can create named slots here, which is kind of cool. I always like that in templating systems that had kind of slot slot systems. Contact card. Now you can put it on the element. Slot name, slot address. I see, because then in here we say slot and the name. It's just assigning those to go into those slots. Pretty cool. And then there's a context API, which is just another way, you know, like React to, and also not terribly unlike Go contexts, but you know, something that you can kind of state that passes down the hierarchy that you can add stuff to and get stuff out of, which I think is a great pattern in general. So good to see it in more places. What's interesting, they have these special elements. So like if you wanted to add handlers on window, you would add them to the Svelte window, and so it would figure out how to do that. So you know, maybe in server-side rendering it just ignores those. I don't know. But same with body and head. Options, a generic way to add some extra metadata to components. So creating a tag here. So what this is really getting at, it's almost like this is a Svelte file. You know, it doesn't have like a containing XML thing, but it's sort of like you could imagine it as like a Svelte document or a component document. In fact, I would consider, instead of using Svelte or whatever the name of the framework is like a .com, because we haven't used that for commands in a long time. But components, I don't know. Sharing code. Let's see here. Script module context. Change code that runs on initialization. Codes outside. For example, you play all 5. So if for some reason there's code that you don't want to be run in the context of initialize, then you can just create a different context for that script tag. By the way, they also in some of their examples will say script lang equals, you know, and this is for their compiler if you're using TypeScript, lang equals TS. It'd be interesting to do a version of a framework like this that is not specific to JavaScript, where you could say lang equals Go or lang equals Python, and it's able to put it all into a WebAssembly thing. So I've never gone through all of these. We skipped the actions and animation stuff. But I left stores for the end because this is kind of interesting. I guess I'll just kind of follow the logic here. Not all application state belongs inside your application's component hierarchy. Properties, whatever. So this is kind of like globals or external sources of data, but the main thing is making sure that you're able to subscribe to the changes. So they basically created a value subscribe kind of API here. It's kind of low level. It works a little bit like React, where you explicitly set its value, say what happens when it's updated. And they had some kind of, so a store is simply an object with a subscribe method that allows interested parties to be notified whenever the store changes. So count is a value. Whenever the value changes, we get this is called, and we can set count value. So this is interesting that by default you would create a variable, a local variable, and then sort of like as this external variable changes, you'll assign the local variable. They have some kind of I guess they call it auto subscriptions. Well, I guess too, you'd want to unsubscribe. The subscribe returns an unsubscribe. Pretty common pattern. Clean stuff up, dispose, whatever. You pass that in on destroy. So now you're doing a lot of stuff. So you can reference a store by prefixing the store name with $. So now you can use it anywhere like this. Very curious. So count is the store that would normally have subscribe, that would return unsubscribe, that you would then have to put in on destroy, as well as any others that you collected. And so this is a shorthand that'll do all that for you. Only works with store variables that are declared at the top level scope of a component. I don't know what that means. I guess if you had like a handler or something, it wouldn't work, but inside markup, you can use it anywhere in the script. Any name beginning with $ is assumed to refer to a store value, making it a reserved character. Different from $: which is a different thing, but so any name that starts with $ is treated like this. So how does this work? I believe count. Count. And it looks like they just wrap it all up in a component subscribe. So, sort of an internal API. The fuck is value? Oh. They're setting count, they're invalidating it, and they're passing the component instance or whatever in as well, so it can add it to onDestroy, I'm imagining. So component subscribe. I want to make a note of some of the functions. I want to see where they live in the source, because that'll give me a hint. Like component subscribe, if we find that in the source, it's probably with a bunch of other stuff that's part of this runtime. These kind of helper things. It's internal API. So we've got readable stores, which are versions that you can't write. I don't know. We've got derived stores. Based on other stores. Custom stores. So you can give it a store with its own methods. Whatever. Store bindings. If a store is writable, you can bind it to its value. Okay, that's intuitive. I would imagine you could. Name. Okay. All right, well, that's pretty much everything in here, you know, what it's capable of, Svelte 3. We've got like 45 minutes before the end of the stream. And like I said, I thought I was going to spend a lot of time in the source code, but really the source code it's generating is what I wanted to spend more time. And I feel like that gives us, anybody that's been watching, a better sense of how it works, because how it compiles that code is not that important. But I will go through the source, and like I said, I looked a little bit at some of the early versions and how it's changed and stuff like that. So I'm going to take a break, and then we'll come back and just kind of run through that and see how things have changed there. BRB. Oh, that's funny. My this guy shouldn't be running because it's taking over my 8080 here. I wonder how this is still running. It's okay with that. There we go. Apparently they're both listening on 8080. I didn't know that was... I guess I do know that's possible, but usually that's not supposed to happen. All right, maybe 5-minute break. It says 10 minutes, but I'll be back sooner. I thought this was gonna have to be a series where I go through every version multiple days, but we got through this in one day. That's good. All right, BRB. So we're gonna look at the source code, but I wanted to thank everybody for hanging out. It's not that this is not exactly what I expected. It's sort of better than I expected, but I hope it was interesting because I'd imagine most people, if they hear Svelte deep dive, they want, you know, how-tos. Let's make some stuff. Here I'm just analyzing it. And it turns out not even really reading much of the source code, but we'll look at some now. Because like I said, I think this should inspire a lot of people to make something like Svelte, because all those sources that we've been looking at, you know, the JavaScript that's been generated, all you have to do is generate that. In fact, if I were to create my own Svelte, I would just also use the Svelte runtime. Or something. Definitely feels like something though that I imagine for, I don't know. Almost makes sense to do it in Rust. I wouldn't want to, but yeah, somebody else can do it in Rust. All right, well, it's been 5 minutes. Let's get back into it and look at some source code. Not this source code. So 5 years ago, 010. Not a big project. There's only a compiler directory. Just compile, it takes a template. This is almost giving a map of like, if you were to make your own, it would kind of evolve like this maybe. Compile, takes a template. I don't know what means by template. The source code now is a lot of TypeScript, but it's evolved from JavaScript. So unfortunately, there are not like indicators of what some of this stuff is, but clearly at a high level, given a template, which is kind of a Svelte file, we'll parse it and then generate. What parsed is, we'll see. Actually, this has not changed very much as I've already gone through and looked at these, but this has not changed a whole lot. Some parse, so we have parse, whatever template is. It's using Acorn. I found out what Acorn is. It's just a JavaScript, what do you call it? Parser. Producing an AST for JavaScript. What would you call that? Yeah, I guess a parser. So they've got some, but they wrap it. And then unnecessary void space. So the output of parse is basically, here's the HTML, here's the CS and JS. This is 010, by the way, so not at all how it works now, but just to see how it started. All it did was take that file and then produce some ASTs for the HTML, CSS, and JavaScript, which would then be passed into the generator. All this other stuff is just support for working with the AST to do stuff. Read event handler directives. So, you know, I'll probably need something to read those custom directives that they've made. Let's see, an expression. I don't know what an expression is here. Or maybe that's the template syntax. I don't know if they had the template syntax in it at this point. But that's basically what the parser is. and then generate. Create a renderer. So again, this is an old version, so this is the code that would generate the stuff that we've been looking at. And so it's interesting to see the minimal early version of that was a basically producing a function that would set up a DOM element, do the update stuff and the teardown stuff. I don't know what magic string is. Probably another parser. Actually, is it? What is magic string? Oh. It's probably for the source maps. Light modifications to it. Replacing a couple of characters. But you also want to maintain the source map. Okay. Source map locations, yada, yada, yada. Parse, we're gonna walk the HTML. This is looking at the HTML. See, this is what sucks, is all the special cases of HTML and the DOM. But in general, it's pretty straightforward. Event handlers, attributes. Got their bindings. I don't know what ref is in this version. Look at that. Yeah, I saw this. So they're definitely, in fact, are they using Mustache? But they refer to it as Mustache, so yeah, Mustache style tags. Create a renderer. I don't know what it is about JavaScript, but because you can just do so many kind of nested callback things, like it's always hard to follow. It's not also the JS style tags. I don't know what you're referring to. Oh, the mustache. Yeah. It's just a curly brace. What mustache is named after, I guess. Svelte component, and then they generate a bunch of code. Dispatch observers. It's really interesting. You know, they had to figure out how to come up with that API that it's generating. Kind of a hard thing. I haven't had to do anything like that in a while. But anyway, that's version 0.1. Like, there's not a whole lot else in there. That was index of generate. There's utils, which is just like stupid utilities. I don't know what binding is. Oh. Yeah, this looks like bindings as we've talked about. If it's an input, it's gonna create handlers and yada, yada, yada. Attributes. Okay, this is just a mapping of what elements use what attributes. So yeah, that's version 0.1. And that worked enough that he tagged it 0.1. We'll look at 1.0. By the way, and I brought this up, this is the 2.0 docs. And so, very different API. Remember, we had the instead of using it being a compiler to use assignment, you'd still use set, you know? I've been looking at these docs trying to get a sense of like how it correlates to the new stuff, and it doesn't map very easily in my head. Maybe some of this stuff correlates to its internal APIs that it's generating code for. So that component API is very weird to me. So that changed a lot between 2 and 3. But all the template syntax is pretty much there. Scope styles, pretty much the same. And I don't know what what 1.0 looks like, or where its 1.0 docs are, but just to kind of see how it evolved. So now we have compiler, parse is in there like we saw before. We've got generate, so it's basically just wrapping everything into compiler. You know, generate's pretty much the same. We've got some CSS related stuff. Damn, looking into switching to Svelte. React is still working so well for me. I haven't really had the need to switch to anything else. Also, pretty neat idea. Get a feel for a project by looking at the earliest versions. Hopefully you'll watch the beginning of this, the VOD, Dan, because that's sort of where the argument for Svelte is, and not even necessarily Svelte specifically, but the approach of Svelte versus something like a React. It's a totally different way of doing frameworks. I would recommend, if you don't want to do that, because we basically watched this video at the beginning, I'd recommend YouTubing, I guess you could call it that. YouTube searching, rethinking reactivity. Maybe throw Rich Harris in there. That's a pretty good talk. Should give you a sense of like, holy shit. No, this is like order of magnitude different. Not only faster, but simpler, but introduces a whole new way of doing things. To the point where it's like, okay, now it's worth thinking about something better than React. So anyway, because you missed all that. But yeah, this is I actually thought I was going to spend most of the day looking at the source code. But because of the nature of this thing being so different, most of today was spent looking at the source code it generates, which was very interesting. So this is really just kind of a follow-up just to see how it evolved. But yeah, I think that's kind of a fun way to look at a project, is through how the source has evolved. But yeah, so 1.0 is not terribly different. We'll look at 2.0 real quick. Now it's like a real project. You can tell by how many files are in here. Still have our parse. Our generator looks like now here they've split up a generator for doing DOM stuff. I think this is sort of a generalized version that they could use for both DOM and server side. So that's another thing, and I don't know if I made that point earlier, but the idea of React using components to do client-side stuff, Rich made all these points too, is a lot of the state stuff, you have to add all this stuff to React to get it to work right. Use memo, all the hooks that they had to come up with, is really trying to like work around the problem with the kind of that worldview. But another example is server-side rendering. I guess I did say like, okay, now if you want to do it, you'd have to create a virtual DOM on the server side and you run all the components as usual, hoping that they're not using any, client-side browser code, render that, and then serialize that, and then output that. Whereas we can do that a lot more efficiently if we just go directly from the source that we're compiling to the output for server-side rendering. But so this is where they introduced that in 2.0, which is pretty interesting. Starting to use TypeScript, but which is a little helpful. Mostly they're defining interfaces, which at least was helpful in starting to read the source code. And like I said, I'm not looking at too much of this because earlier before the stream, looking at this, it's not terribly interesting. It is mostly a compiler, parser generator, which is boring code, But what's interesting is we haven't seen like the code that is run on the client side yet. Maybe that's what shared is. Yeah, because that's where we saw all this stuff like append node, insert node. So I think this is where they started creating what they later called the runtime. Ooh, our create fragment. Simpler is what would get me. Yeah, simpler, not just in terms of like using it, but simpler in terms of everything, both how it's designed to the... I mean, Rich likes to compare it to, EVs, it's like how many parts are in a traditional combustion engine, and then how many parts are in an electric motor. There's like 2 parts or something. It's like that is a game-changing difference in simplicity, and that's kind of what Svelte is getting at. That is hard for people to wrap their minds around, right? Yeah, init here, it looks like an early version of that init function we saw so much of. Yeah, this is kind of where some of the interesting stuff is. But, man, 2.0 is very different. Anything interesting in here? Bunch of utilities. Code builder. As I was reading this, they do have a kind of like chunk, like they have a representation of JavaScript. It's like, I'm kind of guessing chunk type is like, is it a line statement or is it like a block? So it's interesting they're modeling JavaScript since they're both reading it and then having to write it, but at a high level, Some of their tests are interesting to look at too, because you can get a sense of like how you can actually use the API a little. They have these pre-processors, I guess they introduced in 2.0. So you can give it some hooks to, they big example is like TypeScript or whatever, but you can kind of give it any kind of preprocessor, which is interesting. I'm a little surprised that they kind of did this from scratch. They didn't, use another. I mean, they use rollup, but they use rollup just to bundle. Looks like they have a runtime directory now. Oh, this is testing the runtime. I see. So yeah, they're testing the runtime. They're importing shared. So I think shared becomes runtime. Tons of examples. It's interesting that these are, well, effectively Svelte files. They're calling them HTML. Yeah, These are all like really simple things. Crazy good, you know, test coverage, I gotta say. Yeah, this is interesting. So this is, I don't know. They have, maybe they have direct support for custom elements. I don't remember. Anyway, so tests. Yeah, there's really not a whole lot. And what's in server-side rendering? Not much, because I guess it's mostly in the generator. Boring stuff. Visitors. All this stuff is just, you know, it's all walking data structures, working with ASTs. It's like, you know, not interesting code. But there's also not a lot of it, you know. And of course, the benefit then is then you're getting the output, which is this like incredibly minimal JavaScript that's actually included on your page. All right, let's try 3x. I haven't looked at 3.0. I only looked at the latest. What? You telling me there's no root to 3? Alright, so they started including their website. I'm pretty sure. Might even be like an early version of Svelte or something. Lionel, what are you up to? Svelte code walkthrough. Yep. Actually, just wrapping up. The VOD or whatever, the video on YouTube will be there. On Twitch, it'll be a VOD. I guess you're on Twitch, so it'll be a VOD. You can check it out if you want to get a sense of what's Svelte all about, and then learn about it through me reverse engineering it. Let's see. Internal. We saw a lot of stuff from internal. It's interesting. I kind of get now why they have all these kind of procedural style. And actually, is that a thing? It almost seems like they're naming things differently. That's going to be in the output code. Because I noticed they're using underscores. But I think for their all the other source code, they don't use underscores. Maybe that's not true. Maybe I'm making that up. There's a good render DOM. No, I guess they're using underscores everywhere. Odd choice. I don't know. I feel like camel case is kind of the mainstream JavaScript style. So their compile, or their generators now, is now compile. They've got render DOM, render SSR. But now they have all these abstractions, like there's not a whole lot in here. Concept of a block. All these builders. It's really interesting kind of looking at all this stuff again after reading all the output that it's produced. Claim. Oh, that's L. When we're looking at these. What are these short names for? This is create, mount, update. I don't know, I thought there was a claim. Maybe it's not always in there. Yeah, mostly code to write code. And modeling the code that you're writing, which is interesting. CSS, I don't really do a whole lot. I didn't really get into that, but like most things, it's basically gonna change the name of, you know, my scoped CSS is now basically whatever Vue does, right? Your scoped CSS is now has an extra class name generated, and then anytime you use that in your component HTML, it'll rename it to the generated class name. So they add a bunch of motion stuff, which I said was pretty boring. Most of the stuff is like, oh, easing functions, like interpolation. It's boring. It's like game programming stuff. It's interesting, again, that they included all that kind of transition stuff in there. But it's very cool that it's using the CSS engine to do it all. So pre-process, stats, you know, their timing, their compile process time and stuff. But again, I'm surprised how fast it was, but you know it would be a lot faster? Fucking Go. Yeah. Yeah. So, yeah, that's taking... Actually, I wonder why it took that long. We were seeing it a lot quicker before. But then it's like, oh. Almost 2 milliseconds. 1 millisecond. Yeah, if we did this in Go, it'd be nanoseconds, man. Which at that point, you can do it at runtime. You do things on the fly. You don't even need a compile step. The dev server, it could just be production or something. I don't know. I have to rethink about how it... Because it's compiling stuff, I have to rethink about how it would all work anyway. But I mean, that's pretty much it. If we go to the latest version, it's interesting. The source is now highly divided between the compiler and the runtime. So that's nice. All the compile stuff is in here. Got our parser that we saw back in 0.1. Looks pretty much the same. At least in terms of files, there's not like a whole lot more added. Got their pre-processing. And so yeah, runtime. This is all the stuff that's actually included in the code that it generates. I don't know what the fuck this is. Declare module. Oh, is that maybe that's a TypeScript thing? I don't know. I don't know what's going on here. But I don't know what would use this runtime, because it would generate this normally, so maybe these are used as like, I don't know, the defaults. Got our store stuff, which is mostly defining types and APIs for what a store is, because that's all a store was, right? We saw in the docs. Looks like the only work that it does is when you do a derived store. That makes sense. Oh, but most of it was all in internal. So these are all the helper things that it's used. We'll see all the stuff that we've seen, including what the hell that $$ internal type is. It looks like we can see all of it now. And we remember seeing a lot of context. We've seen dirty, the update callback. So now all this makes sense to me. I'm very curious what this claim step is. I don't know what that is. Everything else makes sense to me. Yeah, this was just hard to read, and why I wanted to go through the docs and the generated code just to understand what they're naming things like. Instance, oh, what is instance? Oh, it's something that's passed in, but it's a function. So it's like higher order functional programming is, I mean, that basically is callback oriented programming and is not fun code to read. Like, regardless of whether it's Node.js or whatever, it's like, you know, it makes sense to me now why so many other languages, it's sort of like the callback, yeah, you can do the callback, but really just do it where it makes sense. Like, don't fucking architect your entire code about functions passing functions around. It's so fucking hard to read. It's fine or whatever, but like, I started writing TypeScript like Go, and it's just like, oh my god, this is so straightforward and easy. And because anything can be written in any language, it's sort of, there's like no reason why you have to write it that way in JavaScript. Right? If you can write it in a simpler way in other languages that don't let you write it that complicated way, you can still write it that way, but people don't, because they're like, their minds have been brainwashed with callbacks and higher order functional programming. So here we're defining those. That's interesting. I thought no, okay. Yeah, so this is what we were extending. This is that base Svelte element. Really, it's all just glue code. Man, this is such an interesting system. There's a lot of stuff like, oh, is there window defined? So that's interesting. On mount. That hook that would use to get into the lifecycle stuff. The way it works is there's a current component, whatever instance you're in. If you're running the instance for whatever the current component is, sort of stored as a global that's you get with current component, get that internal data structure, and then push your callback on mount. Very interesting. What's crazy is that this all, like, we're basically done. Like, I don't know, scheduler is kind of interesting. This is where we saw that stuff at the top, right? The code that we bundled in here. We saw 300 lines of stuff that looked like it was just a bunch of helpers and like order of callbacks, execution, flow stuff. So that's all here. Loop, I wonder if, what do you have in here? Isn't there like a interval thing? Yeah, this makes sense. You see this a lot. We saw subscribe a lot. Any kind of store, and then callbacks. Passes callbacks to the store subscribe. Then if your store is something you can unsubscribe from, or if it's a function to unsubscribe, you do that. Or, oh, that's interesting. Oh, it's giving us an empty unsubscribe. Oh, no. That's weird. Anyway, I get the general idea. Oh, here's that component subscribe that I was making a note on. And yep, here's all the other stuff. Utilities. Component gets the internal data structure on destroy, pushes. Calling subscribe, we're just looking at it. Store and a callback. Yeah, all these kind of helper things are interesting. That's, yeah, pretty much it. I don't think there's anything else in here. Maybe await. Their template syntax stuff uses this, but component. Oh yeah, we looked at all this. So yeah, that's all in runtime. I wonder what they differentiate things in internal versus all this other stuff. Like in Go, internal is like, these APIs are changing. I guess that might be what it is. Like these might be public APIs and utilities and stuff. And internal is specifically made to be used by the code that's generated. Man, with that, that's the Svelte source code, right? Like I skipped through a lot of stuff, but like we didn't need to read all that because it's just AST parsing and transforming. It's like I said, it's pretty boring. Like again, the heart of what's cool about Svelte is in this generated code. And that's what we spent most of today looking at. And if you wanted to create your own Svelte alternative, you could start by basically just trying to, you know, create a compiler that converts files like these into source code like this, and you know, that's a transformation problem. Like the design of how Svelte does what it does that's cool is sort of done. The shape of the problem, the design of the problem is done. It's right here. Man, I use that strategy a lot. The hard part. It's like knowing what the essential important thing is in something. It's the design. The implementation doesn't matter. It only matters when your implementation is so complicated enough you can't imagine starting over. And yet it still happens. You have React and you have something like Mithril. It's like Mithril's so simple conceptually, and it's like that's the heart of React. You know, obviously Svelte does a lot more, but one of the weird things is it kind of has to because of the compiling approach. But so I don't know. It's interesting, but I think it is for all the reasons we talked about in the beginning. A very good way to do things. So it's about 7. I'm gonna just shut down now. We can talk for a little bit more. What is your strategy when navigating project code as you're doing? Why compiling is a better approach? You'll have to watch the VOD to get back on the compiling stuff. One is if I could try and summarize the idea that like the approach that React and all these things are doing with a virtual DOM was incredibly innovative and a performance improvement that made a difference when React first came out. But now with this scale of everything, like it doesn't actually make sense that you would, basically he compared it to early versions of spreadsheets. What was it? VisiCalc, right? Took kind of this naive approach of if any value in the spreadsheet changes, go and recalculate every one, which was fine. It worked well enough. It made the Apple II successful with VisiCalc. But then when Lotus 123 came out, they realized, oh, if you figure out which ones are dependent on each other and create a kind of a dependency graph, then you only have to change the ones that need to be changed. But and you think, oh, isn't that what the virtual DOM is about? But you know, you're still having to iterate over these two trees and compare them all. And all the optimizations for that and all the things that fall out of that are extra things that you have to do with these hooks, use memo, etc., yada, yada, yada. The idea of going back to very precise DOM manipulations that are put together in a way that's very simple and to the point. I don't know how to describe it, but you know, using a compiler to get just that code, not only are you making the output much smaller, because it's a compiler, it's automatically doing all this stuff that you would normally have to do extra with JavaScript when you compile it all, you know, bundle it all together and figure out what the dependencies are and get rid of them. When you're compiling code, you only pick the stuff that you need to include, so it's sort of solves that problem already. But so you have this tiny bit of code, and these operations are so much more faster. You're only doing the operations you need to do. And so in the video that I referenced here, you know, there's some great performance demos that show like, no, this is order of magnitude faster. And then also simpler, you know, as comparison to electric vehicles, radical simplicity. So I'm into all of this stuff, you know, to the point where like anything that looked weird about it and the way that Vue looked weird to me, I'm like, no, it's worth it. And the fact that if I were to do my own version of this, I could actually decide some of those. I guess you can't see my screen, but so that's why compiling is a better approach. It's not necessarily just like compiling, it's like how Svelte thinks about this stuff. So watch that video at the beginning of the VOD, or watch the beginning of the VOD. And strategy when navigating a project code as you're doing, well, so I felt like I kind of, on the stream, kind of ran through it because, like I said, I looked at the code before the stream just to kind of get a sense of like, okay, what am I going to be looking at here? And I did take kind of a closer look. I hadn't looked at any of the code we looked at in terms of the code that it generates. So I was basically starting with a high-level assumption of this is what it does and reading the code. But even then, I'm like skipping stuff because it's sort of like, you know, that, oh, this is a parser. Oh, this is stupid functions related to like identifying whether something's white space. It's like all of these, you know, you start getting a sense of, you know, what is, I don't know what to call it, like not domain code. I think that is a huge skill that if you could understand how to read a code base and get to the domain code. So it's kind of like in a Rails MVC app, it's like, you know, all the controller stuff is just going to be like validating and, you know, most of the time the heart of the app is in the model. That's the whole point. So you look at the model classes or whatever. So MVC and frameworks that set things up like that, it's very easy. But for projects like this, where it's like, oh, it's a web framework compiler, ultimately most of the code is the compiler, so that let me skip a bunch of stuff. So knowing what you can skip, what's not important, and it takes a while. Also looking at types, so basically at 0 here, but you're trying to kind of go in order of the imports. So, you know, obviously go to the index.js's first to see what they're importing. I don't know, there's a lot of strategies. I could probably write a whole thing about that because reading code is something people should do a lot more of. Anyway, so I guess that's the answer. And we're out of time. Someone was already trying to call me, so we'll end there. Thank you, everybody. I have a GitHub sponsors. If you were to go to github.com/sponsor/program, you can sponsor my work. You can also follow me on whatever you're watching on, if it's YouTube or if it's Twitch. Gold Buick, thanks for saying hi. Oh, you are a sponsor. Of course you're a sponsor. Thank you for that. Thank you all, sponsors, anybody here that's sponsoring or just been following along a lot of my work. Yeah, this was fun. I'm surprised it all happened in time, and it was just one day. I'm pretty happy with what we accomplished, and so I'm kind of... I mean, it's going to be a 3-hour VOD, but it's a good one. All right. See ya.